All right, let's go ahead and get started with geospatial analysis. So a couple of notes here as we get going. The first thing is we're going to be using the to start the Ggmap package. So make sure you have that loaded. And then also we're using some Google functionality through Ggmap. And so this used to not be required, but now you're required to have an API anytime you ping the Google servers to get information. And so what I've done is I've listed my API key. Here you can register it with this function, register Google, and then the key name. And I'll also take this key and put it in the chat. So you can just copy it and paste it into your workstation and use it today. After about 48 hours, I'll cancel that key and get a new one so that you guys can't continue to ping Google on my API. But there's instructions in today's folder on how you can register for your own key. But unfortunately, like before you get too far doing this type of analysis, you're going to have a key. So if this is something that's useful for you, then make sure you go out to Google and grab that. And there is a fee associated with it, but I've never been charged anything because you have so many free hours to begin with, or so many free like gigabytes to begin with. If you're going to like create an app that gets downloaded a million times and you're using the Google backbone to do it, then you're probably going to get charged, but I have yet to be charged, even with sharing my key with all the students. All right, the other thing before we take off running in this lesson is we're going to be talking about geospatial information. So if you're not familiar with some of the terms for mapping, charting, and geodesy, like maps, projections, coordinate reference systems, raster versus vector type objects, etc., then there's a list of those terms and their definitions sort of in the middle of today's lesson. So just take a look at that so I don't confuse you with anything that I'm talking about in the lesson. All right, so the idea behind what we're going to do is we talked about all the different ways that you can make ggplots. And to do that, like all you really need is the ggplot function, and then essentially like an X and a Y and a geom layer, right? And it maps everything from your data to the appropriate X and Y axis, and it creates your plot. So when we work with geospatial data, we're essentially doing the same thing, except that the background is not going to be this gray background with, you know, white tick lines. It's going to be a map. And instead of the X axis, we're going to have longitude, and instead of the Y axis, we're going to have latitude. And other than that, that's about the only thing that we're changing. All right, so that's why I went through this whole like review of ggplot, because ggplot does all of the same things that ggmap does in a very similar fashion to give you the visualization or the analysis that you need. All right, so getting started with just a quick run through of creating maps with overlaid geospatial data in R. So we're going to use the Chicago crimes data set, which is in your folder for today. It's called Chicago_crimes.csv. And that includes all crimes from, I think, 2018 in Chicago. So go ahead and set that file in your working directory, and then we're going to go ahead and load that into R. It's a rather large data set, so it'll take just a second here to grab everything and put it in your environment. The other thing, and I probably shouldn't have done this, but I did anyway, is I changed the names for the categories in here to these, the ones that are shown on my screen. So if you go ahead and use the column names function to change the names, then you'll have the exact same thing that I do. If you don't, then you can just use the original Chicago data set headers. All right. So let me run that, and then let's take a look at what we actually have in this data. So the very first thing is the case number that the Chicago Police Department assigned to that crime, the date that it occurred, and that's currently stored as a factor type variable, so we would probably want to change that. We've got a couple of measurements for location that aren't like precise locations. We have block, and then I think the beat and the ward are also location variables. IUCR, I don't know what that is. Offense, so that's the actual crime that occurred. So you've got, you know, arson, assault. You've also got homicides, domestic battery, etc. And then because some crimes have more than one offense associated with it, you've got the secondary offense, location type. I don't know what that is. We're not going to use it. Whether or not there was an arrest made, whether or not it occurred in the home or outside the home, that's the domestic variable. And then FBI code. And then down at the bottom, you have 5 location variables, XY coordinate. So we're not going to use that one. We're actually going to use the ones that are labeled latitude, longitude, so lat and long. And then at the very bottom, you've got this location vector, which actually includes the lat and long for each of the observations, which can actually be very helpful because a lot of the plotting software that you use in R takes a vector of both lat and long as its arguments, and so you can just use that location vector rather than having lat and long split out. All right, so that's what we're working with. Before we get too far, a lot of times when you're working, like I said, with mapping data, and we have a somewhat large data set here, it's a lot of information floating around, a lot of maps that it has to go out and grab. And so it helps to, especially if you're just doing like some exploratory data analysis, subset your data so that it doesn't get too bogged down trying to create that plot for you. So what I'm going to do is I'm going to create this data set murder that is a subset of my Chicago data set, and I'm only looking at homicides, so only murder cases. And luckily, because it's Chicago, we still have a pretty sizable data set. We've still got 539 murders that took place in that year. All right. So before I actually do anything with this data, I want to do just a quick Qplot example because I didn't delve too far into it when we were talking about ggplot, and I want to make sure that everybody understands what's going on here. So there's this function Qplot, and this is a ggplot quick plot. And what it takes as its arguments is an X and a Y, your data source, and then the geom layer that you want to create. And then you can add a bunch of aesthetics on top of that if you so please. So what we can do is I could take the MC cars data set and say I wanted to plot the weight of the car against the miles per gallon. So I would say, give me weight as an X, miles per gallon as my Y. The data is MC cars, and the geom that I'm going to use is geom point. So the scatter plot, whoops, got to be equal to. And then anything else that you put in here is essentially treated like an aesthetic. So if we said, let's make color equal to the number of cylinders that the vehicle has, and then we plot that thing, it's going to give us this little quick plot. All right, and so we see when I blow up this graph, weights on the y-axis, miles per gallon weights on the x-axis, miles per gallon on the y-axis. The color of the point is the number of cylinders that the vehicle has, and that's our plot, right? So there's something very similar in Ggmap, and that is the QM plot, so quick map plot. So if we go quick map plot, we need to give it an X and a Y. So like I said before, X is going to be your longitude, so we'll do LON. Y is going to be the latitude, and these are from the column names off of the murder data frame. So the data itself is going to be the murder object. And we'll go, hey, let's make color equal to whether or not the crime occurred domestically. And then let's go size equals, and I'm going to say 3, but because everything is treated like an aesthetic, we're going to have to use that inhibit function and say size equal to 3. And so when we run that, what's going to happen is it's going to use our key to run out to Google, grab the appropriate map tiles, and then bring those back, use them as the base layer, and then plot latitude and longitude, each of those points onto the map that we've created. All right. And so you see like all these red dots are murders that occurred outside the home, and then the little blue dots are murders that occurred domestically. All right, so now we have a good visualization, or at least a visualization of homicides in Chicago for a given year. All right, so that's where we're going. We can continue to use QMplot and create the quick plots, but a better way to do it, and a way that you can customize your graphs a little bit more, is to use what's called the getMap function first. And getMap will download the images for the mapping tiles that you want, use them to create a Ggmap object, and then that Ggmap object can be fed into a Ggmap plot the same way that a data frame would go into a ggplot plot to create an overlay. All right, so we're going to use getMap to get the map tiles, and then we're going to use Ggmap to actually plot the map tiles. All right, so let's go ahead and start with the getMap function. Like I said, that's going to be used to download map tiles, and all we need to give it really is 2 arguments: the location for the map tiles that we want, and then a level that we want to zoom down. All right, so let's get a map of the White House. So we're going to start out by naming our mapping object, or the resulting mapping object, President, and then we'll use this getMap function, and it's actually get_map. We need to give it a lat long, so we're going to say combine, because we give it to R as a single vector. So we'll say lon is equal to negative, and this is the White House location, negative 77.0365, and then latitude is 38.8977. And then we need to give it a zoom level, like I said. So we'll start out with zoom level 17. Zoom level 3 is like continent level. And then the higher you go, up to 20, 20 is the highest zoom level you can go, you zoom in. So at zoom level 20, you're like basically on top of the center of the White House. Like all you can see is the roof. All right. All right, so let's run that. And when you run that, you see that R goes out to the Google servers, looks for that latitude, longitude, and then pulls it down into, in this case, a Ggmap object called President. And if you wanted to, you could explore some of the attributes that are included in that Ggmap object. All right, but all we need to be concerned with right now is, okay, what do we do with it? And what we're going to do with it is we're going to feed it into the Ggmap function to create a plot. All right, so we're basically going to call Ggmap with our object President to see what that looks like. So I'm going to run that down to my plot area. I get this little plot, and when I zoom in, I see that at the center of the plot is the White House, and then I can see a little bit of the DC area around it. All right, so I've created just a little map here. So one of the really nice features about the getMap function is it's essentially a wrapper for a bunch of different get, map, and this is going to be a poor way to say it, but other getMap functions. So the first one is, in the default setting, is get Google Maps. So what it does is, like, for all the Google Maps that are out there, it goes out and it grabs the one that's appropriate. There's also get OpenStreetMaps and get Stamen Maps. getMap is a wrapper for all of those things. All right, so because the default setting is tied to Google, instead of putting a lat long in here, which is tedious and kind of a pain, we can just search on something. So I can search on the White House, for example, and then define my zoom level. So I'll just do 15 again and go in and grab that map. And then once my mapping object is created, and you'll see at the bottom here, the White House, the search term is not uniquely geocoded. So we're using 1600 Pennsylvania Avenue Northwest, Washington, D.C. 20500. So that's exactly what we want as the map that it gets. So now, once I bring that back, I just call Ggmap again and make sure that I got the right image of the White House. And it looks like I do. So White House is right here at the center, and then I have a greater extent of the Washington, D.C. metropolitan area. All right. And just like we had QMplot and QPlot, we've also got this function QMap. So I can call QMap, and what that's going to do is basically combine, if I just want a map, this is going to combine getMap and the Ggmap call to display it into one line of code. And so I could say get map, and let's do my high school, which is Galesburg High School in Illinois. Again, I'm just searching on it. The case of the terms that you use doesn't really matter. There's a couple of Galesburg cities out there, towns out there, but hopefully it'll get the one in Illinois. And then let's do zoom level, we'll go 17. And by default, the source is Google. So let's keep it at Google. But instead of getting just a, actually, let's just run this. So let's run this and see what it looks like. And you can see by calling just this single line of code with Ggmap, it goes out and it grabs the map. And then it should give us a picture of Galesburg High School. And it is on Fremont Street. Yep, so that's correct. So it looks like it got the right map. Now, if I wanted, instead of just the regular like Google map, if I wanted a satellite image, I could use this same line of code, but then instead of leaving the map type as the default, I could say map type equal to satellite. And this will go out and get me a satellite image of my high school. So when I zoom on that, I can see here's the high school, here's our football field, this is the swimming pool where I used to spend all my time, and that's Galesburg High School, right? So what I want you guys to do is just, because I know you want to play around with this, spend some time, mess around with searching on different things, do different zoom levels, and then you know, look for some stuff that you're interested in. Try to like test it out, like give it like partial addresses, see how good it does at searching on some different terms. And then for the sources and for the map types, take a look at the Ggmap help documentation. And so you can see all the different arguments here that you can use for map type. So, and not all of these are available for all the different sources. So for example, like OpenStreetMaps, you know, may not have the roadmap map type, but you could do these three sources, OSM statement and Google, and then the different map types to see what each of those offers. And just like I said, just play around with it, see how good it is at grabbing the appropriate thing, make sure that it's accurate, and just get used to like going out and grabbing map information, bringing it back and plotting it. All right, and while you're at it, maybe take a look at what's included in the Ggmap object and become a little bit familiar with sort of the structure of those types of objects. All right, so that's the end of the class, and I will talk to you in just a sec on the next video.